to the last speaker of today and of our second e-conference. And the speaker is Dr. Obioha Uwakonye, and he's from Biafra, Africa. He's lecturer, researcher, and design architect at Covenant University of Nigeria. And this presentation will be about generative design, profiling the mathematics of architecture and the connectedness of humans and machine. So please, Dr. Obioha, you may start your presentation.
Hello, please can you confirm that you can hear me? Okay.
Yes.
First of all, I want to thank IWRI for giving me the opportunity to be a part of this e-conference. I consider it a singular privilege to be here today. And my presentation for this e-conference is Generative Design, the mathematics of architecture and the connectedness of humans and machines. Please, I beg to share my screen. And I also promise Seje that I will speak slowly. Okay. Now, mathematics has always been around us, and it's almost practically impossible for anything that was made without the help of mathematics. And because of its abstractness, mathematics is universal in nature than other fields of human thought. It finds applications in business, industry, music, historical studies, politics, sports, medicine, agriculture, engineering, social and natural sciences. And its relationship with other fields of basic and applied sciences, especially strong. And this is for several reasons. The alliance between architecture and mathematics has a long history, dating back many centuries. And architecture provides mathematics with interesting problems to investigate. And in turn, it provides architecture with powerful tools that they can use in analyzing data. Often, abstract patterns that have been studied for their own sake by mathematicians have turned out much later to be very useful in science. And science and mathematics are both trying to discover patterns and relationships, and in this sense, they're part of the same endeavor. And in the past, architecture was considered to a mathematical topic, and the disciplines have up to the present time retained close connections. We all know that mathematics is the chief language of science, and this symbolic language of mathematics has turned out to be extremely valuable for expressing scientific ideas unambiguously. Because when we see statements like A equals to F over M, it is not simply a shorthand way of saying that the acceleration of an object depends on the force applied to it and its mass. Rather, it is a precise statement of a quantitative relationship among these variables. More importantly, mathematics provides the grammar of science, the rules for analyzing scientific ideas and data rigorously. And it's important to know that mathematics and architecture have many features in common. And they include a belief of understandable order, an interplay of imagination and rigorous logic, ideas of honesty and openness, and the critical importance of peer criticism, the value placed on being the first to make a key discovery, being international in scope, and even with the development of powerful electronic computers, they had made it possible to use technology to open up new fields of investigation. In the past, mathematical principles have been developed with the human body, called the golden ratio. And now this golden ratio, otherwise known as the divine proportion of phi, is a mathematical ratio with special properties and aesthetic significance. An enormous number of things in the universe are engineered around this ratio, ranging from the human body to the Ark of the Covenant to snare shares the orbits of the planet. And that brings us to the Fibonacci idea. Now, the golden ratio, it is believed to be most aesthetically pleasing and harmonious means of design. And statistical analysis, it indicates that the people involuntarily give preference proportions that approximate to this ratio. From this principle, a French architect, Le Corbusier, developed a mathematical model used in architecture called Le Modular. In this modular system, the architect used the golden ratio when the relation between two dimensions is the same as that of the sum of both and the greater of the two, which he described as a tool of linear or optimal measurement, similar to musical script. We can look at these particular slides that shows the human body and the relationships between the different parts of the human body. Like the shoulder span is considered to be 1/4 of the height of a human being. Like the root of a male reproductive organ is considered to be at a precise position of being half of the height of a human being. Now, this idea was also taken to another level by a German architect, Ernst Neufert. He used the same principle to develop ratios with the human body that can be used in architecture. This principle, with the advancement in mathematics and computer algorithm, it has led to the development of a concept in architecture that is known as generative design. And it is a process that uses the power of computing algorithm to evaluate and iterate on these often conflicting architectural design requirements. These requirements that often span not only engineering, but materials and construction requirements as well. And it is making possible the ability to realize new designs that would never have been imagined without it. The system supports calculation and simulation realization. In fact, the use of more efficient tools will provide for more satisfactory solutions. This symbiotic relationship between the generation and the testing components, it will lead to a larger set of attainable solutions and can assist both the design team in developing intelligent, sustainable, and superior designs. Generative design is, as a matter of fact, a paradigm shift in design. It's actually changing how architects interact with the computers and design software. Now, instead of computers simply acting as a repository for easy access to designs, it is now working with architects in generating these designs. Generative design for architecture, as a matter of fact, is a new method of design, and it enables architects to discover unexpected novel designs and navigate trade-offs between high-performing designs, sketch constraints, and goals rather than form, and co-design between humans and computer. It is actually a departure from the way that we have traditionally done design. But these technologies, they are not a threat to humans. They are more like supercomputers. In fact, some scholars have told you that they are just like a design assistant that assists the architects in generating architectural design. And these are developed from the model. As a matter of fact, we as architects, we are really interested in exploring the aesthetic consequences of this evolution of technology. Now, our role in generative design as a user, as a designer, it has completely changed from this direct relationship with the computer. When we say, okay, here, do this in this way, place this line here, remove this wall here, place it here, make this wall here in this part of the building. Now the architect becomes more like a curator Generative design, it promises to save time on the design process and save materials by creating the most efficient structures and save money by working out the most cost-effective way of to manufacture them. As a matter of fact, the module that was developed by Le Corbusier deals with a concept that says that 300 times n, 300 now being the constant, and 300 is considered to be 1 foot, and 1 foot in actual fact is the average length of a foot of a human being. Now, in generative design, we humans will be less in the business of forming or 3D modeling, and more in the business of really understanding what are our requirements in the design process. What do we really want in that scheme that we're working on? What are our boundary conditions? What are our constraints? And what is our operational assumptions? And this is the kind of thing that humans are better at. And now, when you combine this technology with advancements in additive manufacturing, 3D printing on an industrial architectural scale, it has the potential of to fundamentally change how we look at architecture. Now, instead of designing building envelopes that is made up of separate layers from heating, ventilation, passive solar gain, and other necessities, these needs could be accounted for within a single complex scheme that possesses qualities that mimic biological organisms. Now, the possibilities are startling. Water and gas could flow through man-made veins, integrated into walls, rendering pipe work a thing of the past. Solar data could generate transformable windows that allow light to enter interiors at precisely the right times of day for the needs of inhabitants, meaning that louvers and blinds are banished from buildings for good. The internal structures of metals and carbon fiber elements will be optimized like animal bones, allowing even larger column-free spaces, water-thin staircases, and the most dramatic cantilevers yet. It remains to be seen how software and hardware develop in light of this advancement. But one thing is for sure, both architectural design and the construction process will begin to look very differently as computation plays an ever greater role in the industry because of its relationship with machines and humans. Thank you. Well, I'm done with the presentation. Please, if you have any questions, I'm ready to take your questions.
Thank you very much for your wonderful presentation. I would like to ask about the practical outcomes. Have you implemented your ideas in any architectural design in any place?
Yes, this has been used in architectural design today. In fact, as a matter of fact, generative design is the current best practices in architectural design. And digital architects, this is where everybody is now and where everybody should be. It is a system where the computer is no longer seen as just a tool, where like they say, garbage in, garbage out. It now gets to a point that we humans will now start looking at these tools as our assistants. Now, the things that we do before, we now give those responsibilities to the machine. And now we human beings will now start doing the things that humans are best at, that is taking decisions. At the end of the day, using these tools can help you to generate up to 10,000 different options of a particular design concept. Now, you can now start optimizing these options by selecting certain criteria. And as you select certain criteria, the generative design tools will continue to sift through your options and iterate through them and now give you options. It is not left with you as a human being to now select the ones that suit your emotions. Thank you.
Thank you very much. A question came in from Facebook from Miss Cynthia Capitanacci, and she's asking, how the science itself show us more and more integrative laws in all its branches.
Please come again.
I'll repeat, how the science itself show us more and more integrative laws in all its branches.
Okay, if you look at the Fibonacci rule, the Fibonacci rule actually is a mathematical concept. This mathematical concept goes into details and gives you the mathematical relationship even in the petals of a rose. So this is science, and it's science that is in connection with humans, because the development of these tools has a lot to do with the modular concept, using the human foot as a guide to determine sizes. And like in the presentation, you hear where I mentioned that it goes to the point of biological mimicry, which means humans and machines are now combining to advance humanity and nature.
Thank you very much. And I see a raised hand from Joshua Johnson Umazurike, so please ask your question. And this will be the final question.
Hello, Obioha. Thank you very much for your presentation. This is very striking to me, so I have some questions for you.
Okay.
And I wanted to know if at all there's a software being developed, if there's one, would you be interested in commercializing them?
Well,
these are my two questions.
Okay. Generative design tools are developed by Autodesk. Autodesk is the leading software developer in graphic tools, and a particular tools that was developed for this for generative design is called Project Refinery. So Project Refinery is actually the tools that is used in generative design. So it's now being commercialized by Autodesk.
Oh, okay. Can anybody use this?
Yes. Now, this concept is being used even in all parts of manufacturing concerns, not only in architecture. Nike, all those companies that produce sportswear, even to the minutest details, the way they design sportswear, even for swimmers, if this thing can be able to help an athlete to gain even 1/10 of a second, and that can make a difference between a loser and a champion.
Thank you very much.
Thank you.
Well, thank you very much for the wonderful presentation. It was very interesting.